The air hung thick with the scent of lilies and fear. Mrs. Hathaway, a woman draped in silk and worry, pointed a trembling finger towards the empty safe. "Gone! They're all gone!" she cried. Her prized jewels, a collection spanning generations, had vanished. Detective Harding, a man known for his methodical approach and sharp intellect, stepped into the lavish room. He surveyed the scene, his eyes missing nothing. The chaos of the robbery was evident, yet amidst the disorder, Harding sensed a pattern, a whisper of logic waiting to be deciphered. Harding began his investigation by meticulously documenting the scene. He noted the shattered window, the overturned furniture, signs of a struggle, but nothing to point towards the culprit. He interviewed the staff, each offering a different perspective, a different piece of the puzzle. The gardener, a stoic man with dirt-stained hands, mentioned seeing a suspicious van in the neighborhood in the days leading up to the robbery. The housekeeper, her eyes red-rimmed, swore she heard a muffled sound on the night of the theft. Days turned into weeks, frustration mounting with each passing hour. Harding pored over the evidence, his mind buzzing with possibilities. He felt like a man lost at sea, surrounded by a vast ocean of information with no compass to guide him. Then, a breakthrough. A young officer, fresh out of the academy, approached Harding with an idea. "Sir," he said, "what if we used linear regression?" Harding, intrigued, listened as the young officer explained the concept. Linear regression, the officer explained, was a way to find relationships between variables. It was like drawing a line through a set of data points, a line that could predict future outcomes. Harding, his mind latching onto the idea, saw a glimmer of hope. He realized that the seemingly disparate clues were not islands but points on a map, waiting to be connected. He just needed the right tool to draw the lines. Section 2. Clues and regression lines. The gardener's sighting of the van, the housekeeper's recollection of the muffled sound, the shattered window, all these clues could be plotted as points on a graph. Time of day, location, frequency of suspicious activity. These were the variables that could be connected. It was like a giant game of connect the dots, and linear regression was the pencil. Harding learned that there are different types of linear regression. Simple linear regression, the officer explained, was like drawing a straight line through a set of points. It was the most basic form, useful when there was one clear independent variable, like time, influencing a dependent variable, like the frequency of suspicious activity. Multiple linear regression, on the other hand, was like drawing a line through a multidimensional space, accounting for the influence of several independent variables. As Harding delved deeper, he discovered the concept of logistic regression. Unlike its linear counterpart, logistic regression wasn't about predicting a specific number, but a probability, a likelihood of something happening. Was it likely that a particular car seen multiple times near the Hathaway residence belonged to the thief? Logistic regression could provide an answer. Armed with this newfound knowledge, Harding began plotting the data. He created a scatter plot, each dot representing a clue. He drew lines, tentative at first, then bolder as patterns emerged. He saw that the van sightings increased steadily in the days leading up to the robbery. The muffled sound, reported by the housekeeper, coincided with a spike in van activity. It was as if the chaos was coalescing into a story, a narrative whispered by the data itself. Section 3. Connecting the dots. The regression lines, like threads of light in the darkness, illuminated the path towards the culprit. They revealed a clear correlation between the van sightings and the eventual robbery. The frequency of van activity peaked on the day of the theft, then vanished completely. Harding, his eyes gleaming with understanding, realized that the van was not just a random detail but a critical piece of the puzzle. He focused his attention on the van. Its description was circulated, leading to a tip from a pawn shop owner. The owner recalled a man matching the gardener's description, attempting to pawn jewelry that resembled Mrs. Hathaway's missing collection. Harding, his instincts honed by years of experience, saw the pieces falling into place. He visited the gardener's home, a modest cottage on the outskirts of town. Inside, hidden beneath floorboards, Harding discovered a cache of jewels, Mrs. Hathaway's stolen treasures. The gardener, confronted with the evidence, confessed to the crime. He had been observing the Hathaway household for weeks, using the van as a cover, waiting for the opportune moment. The case, once a tangled web of uncertainty, was now neatly resolved. Linear regression, a tool that seemed abstract at first, had provided the framework, the scaffolding upon which the solution was built. Harding, once lost in a sea of information, was now steering a steady course, guided by the compass of logic and statistics. Section 4. Linear regression in the age of AI. The Hathaway case, while significant in itself, unveiled a much broader truth. The power of linear regression extended far beyond the realm of solving crimes. In the burgeoning field of artificial intelligence, linear regression was a cornerstone, a fundamental building block upon which complex algorithms were built. Machine learning, a subset of AI, relied heavily on linear regression. From predicting stock prices to analyzing consumer behavior, from medical diagnosis to personalized recommendations, linear regression was the engine driving countless applications. It was the silent force behind spam filters, voice assistants, and self-driving cars. Consider the world of online shopping. E-commerce giants, armed with mountains of data, used linear regression to understand customer preferences. They analyzed past purchases, browsing history, and demographic information to predict future buying patterns. The result? Personalized recommendations, targeted advertising, and a seamless shopping experience tailored to each individual. In healthcare, linear regression played a vital role in medical diagnosis and treatment planning. By analyzing patient data, age, medical history, lifestyle choices, doctors could predict the likelihood of developing certain diseases. This predictive power allowed for early intervention, personalized treatment plans, and ultimately, better health outcomes. Section 5. Beyond the line limits of linear regression. Linear regression, while a powerful tool, was not without its limitations. Its effectiveness hinged on the assumption of linearity, a straight-line relationship between variables. In the real world, however, relationships are often more complex, influenced by a myriad of factors that don't always fit neatly onto a straight line. For example, predicting the price of a house based solely on its size would be a simplistic approach. Other factors like location, number of bedrooms, and overall condition of the property also play a significant role. Ignoring these nuances could lead to inaccurate predictions, highlighting the limitations of relying solely on linear models. Furthermore, linear regression was susceptible to outliers, data points that deviated significantly from the overall trend. These outliers could skew the regression line, leading to misleading conclusions. Consider a study analyzing the relationship between income and happiness. A billionaire, despite their wealth, might be profoundly unhappy, creating an outlier that distorts the overall correlation. Despite its limitations, linear regression remained an invaluable tool. Its simplicity, ease of interpretation, and computational efficiency made it a go-to method for countless applications. However, it was crucial to recognize its limitations, to understand that the real world, in all its messy complexity, often defied the neatness of a straight line.